Welcome back to the shop. Today, little video is going to be about converting a carbureted Honda CB400F to fuel injection and turbocharging. I had a few people asking me about some of the details of how I did this, so I thought I'd make a little video about it. I figured I'd start off with right at the bottom with the oil pan. I needed to make a new oil pan for a couple of reasons. One, I'd tilted the engine forward a bit to get better clearance on the intake side to the frame, and secondly, I needed to increase the space from the oil level to the oil outlet of the turbo. The stock oil pan holds about 2 liters, and then the other 2 liters of oil are actually held in the crankcases. I needed to get that down so that I had a clear vertical drop out of the oil outlet on the turbo into the oil pan. So I built a new oil pan that is much longer and much deeper, and so now I've got a near vertical drop out of the turbo into the oil pan. Here you can see the two lines representing the old oil level and the new oil level, and you can see that the new oil level's much lower in relation to the turbo drain outlet.
Another thing I did for convenience sake was I machined an adapter to use one of these spin-on type oil filters instead of the old Honda paper element filters. This is much smaller and just easier to change and everything else. This adapter plate also contains the fittings for the oil cooler and the oil feed line. On the other side, you can't see it right now, but on the other side is the oil feed for the turbocharger. Another issue with an old bike like this and trying to fuel inject it is the alternator system on this old bike only put out about 150 watts of power, which isn't enough to run the computer. The fuel injection computer needs a nice constant supply of power all the time. So this is a modified CBR600RR, I think a 2003 to 2005 unit, and the challenge with this one, the big challenge, was that the taper inside this rotor is much bigger than the taper that's on the crankshaft for the 400. So I had to machine up a spacer that goes in there. It's got an internal taper and an external taper. The internal taper fits the Honda 400 crankshaft. The external taper fits the inside of this rotor. The actual angle of the taper is exactly the same. So the inside angle and the outside angle were the same. It just needed to be machined up. The tricky part of doing that is that establishing the correct diameters, because if one diameter is bigger or smaller, it actually moves the rotor back or forward. Here's the actual modified stator and cover. I took a standard 400F cover and machined the face of it off, installed a new mounting plate, and mounted the new stator to it. So there it is. On the ignition side, and I don't know if you can see through the window here, this little black piece is the ignition pickup from a CBR600RR 2003 to 2005, and maybe you can just see the teeth. This is running a 12-1 tooth ignition rotor. So I just had to machine up this adapter plate that carries the pickup, and there's a little window here that allows me to see the timing marks for top dead center. So I'm running a Microsquirt computer controller, and I'm using it for the ignition also. So the nice thing about that is it doesn't care, it doesn't matter where you place this pickup in relation to top dead center, because you can just adjust that in the software. The clutch, stock clutch with Barnett fiber plates in it, stock springs. The Barnett plates, they hold really well. They're kind of shitty as far as clutch release. They tend to drag, and if you don't ride the bike for a while, like if it's sitting over the winter sort of thing, the first time you go to engage these things, like, they are frozen together. It's a real bugger to get them to break apart. But they do hold well, so I haven't had any problems with clutch slipping. Bottom end is a stock bottom end, stock connecting rods, and stock pistons. The compression ratio on those are only 9:1 stock, so it's really not very high in terms of turbocharging. And they're so small, they're only a 50mm piston, so just a 2-inch bore. The combustion chamber is so small that detonation just isn't an issue. Just running premium pump gas in it, I haven't had any issues, and I've been running 10 psi of boost. And as far as the connecting rods go, I haven't had an issue with them so far. If I was to go any wilder, I would definitely be looking at some different connecting rods, but so far these ones have worked okay. So on the intake side, as I mentioned before, I wanted the stock carburetors mount at a horizontal angle. I wanted to tilt everything up a bit, so I machined off the mounting flanges at an angle to give a bit of a better mounting angle for the intake system. There's the temperature sensor. I drilled into the head and made an adapter to accept the standard GM temperature sensor. So it's reading some combination of oil temperature and cylinder head temperature, because it is actually right through into the oil inside. So that's always a challenge with these air-cooled engines. How do you get the temperature reading for the fuel injection system? But that's how I handled it, and it seemed to work pretty good. Stock valve springs, again, you're running the stock red line with a turbo engine, so there's really no need for heavy-duty valve springs. So here we are looking at the header system that was built out of 1-inch pipe L's, stainless steel L's they're called, which is short for elbows. That was about as short and as high as I could get the turbo. I needed to try and get the turbo up as high as possible so that I had enough room left at the bottom for the oil to drain. So that was about as high up and as tight into the motor as I could get. The turbo itself is a Z20 that are available off of eBay or Amazon. You know, dirt cheap, couple $100 US. And I don't know what the lifespan would be on it. It's probably done 7,000 to 8,000 kilometers last year, and it's still running fine. So I'm not sure what the lifespan would be. A real one, it's based on a RB, an IHI RB03, and a genuine one of those is about $650 US. So depending on how many miles you plan on doing, you could buy 3 or maybe even 4 of these cheap Chinese ones for the price of a real one. So I don't know. I had thought about getting a real one, but I don't know. Well, maybe sometime in the future. There's a Kinagawa wastegate, the original wastegate that came with the turbo. I tried it with that when I first had the bike running. It was easily jumping to about 10 or 12 psi, which was too much, I thought, for the very first trials and everything, until I got everything dialed in, and it wasn't adjustable. So this one is an adjustable. Comes with different springs, and then you can adjust the tension on the rod to adjust the preload on the spring to get the pressure that you want. On the intake side, I made this little manifold, and it gets a K&N filter. Here's the lower plenum. So there's the bodies that attach to the cylinder head, and there's the spigots where the throttle bodies attach. And if I flip that over, there's the injectors underneath, and there's a couple of aluminum fuel rails that I made. So there's the main fuel coming from the fuel tank into a splitter that splits it off into the 2 fuel rails, and then each of those rails feed one of the injectors. The injectors are the lower injectors off of the 2005 CB400F RR. They're about 200 cc's, I think, per injector. So on top of the lower plenum is the throttle body assembly, and that's half of a CBR600 throttle assembly. So there's twin 38mm bores in there. I blanked off the injector ports because I've got the 4 injectors down in the throttle bodies. I don't need them in these adapters. I don't need them in these throttle bodies anymore.
The CBR600 RR uses what they term a wax unit to control the cold idle. So it's a sealed chamber filled with wax, and the coolant circulates through the unit, and as it gets warm, the wax expands, and it opens up a series, or when it's cold, there is a series of jets in the throttle bodies that are open, and as the wax expands, those jets close off and lower the idle back down. I could never get it to work. There wasn't enough range without the coolant running through it, and just relying on engine heat itself, there wasn't enough range from open to closed. I kept the manual adjuster for adjusting the overall idle, and then I 3D printed a mechanism that just holds the throttle bodies, or the throttle plates, open a little bit when it's cold. So just almost like a choke system, you just flip the little lever, it holds the throttle plates open a little bit, and when it's cold, that'll keep it running at about 3,000 RPM. And then as it warms up, the RPM start rising. You can just slowly turn it off, and it'll fall back down to its regular warm idle.
Over on the other side, there's the Honda throttle position sensor, just like it comes on the original throttle bodies. There's a vacuum hose that hooks up to that lower plenum, and it goes into the blow-off valve. So there's a little TurboSmart blow-off valve, and it's hooked up into this upper plenum. The lower plenum also contains a fitting for the MAP sensor, and it also contains, over on the other side, I'm not sure if we can see it or not, it also contains a fitting that runs to the turbo boost gauge, and it contains a temperature sensor that isn't required really, but the COSO digital dash gauge that I have has 2 temperature sensors available. So I've got one showing the intake manifold sensor, and I've got a second one that then shows the oil temperature. So now we've got the intercooler in place. I sized that with the help from the engineers at Bell Intercoolers. I gave them the flow rate and the engine size and everything like that, and that's the size of intercooler that they came up with. And I built the end tanks for it. And then there's the intake tube running up into the upper plenum. Down in the bottom of the intercooler is a GM air temperature sensor. I'm hoping that's a better place. I had it up on top in I had it in the upper plenum, and it was doing strange things where the bike would run perfectly fine, and then you would go for a long ride, and all of a sudden you'd get to an intersection and it would just stall. And we finally figured that was heat soak, that the temperature sensor being up on top so close to the engine was giving a false temperature reading for the incoming air. So hopefully moving it back down to the intercooler fixes that. Here's two GM MAP sensors. One of them is a 2-bar MAP sensor, the other one is a 1-bar MAP sensor. The 2-bar MAP sensor is hooked up with a vacuum hose to the lower plenum. The 1-bar MAP sensor just sits there and it is reading ambient pressure. So the 2-bar sensor is reading the manifold pressure, and the 1-bar is just reading ambient temperature and ambient pressure. So the last change that was made to the engine, I guess, is this oil cooler. Big Earl's curved oil cooler, and it really keeps the engine cool. I thought with the turbo on it, it probably needed all the cooling it could get. It's recommended even on stock 404s to put an oil cooler on them. With that oil cooler on, the engine temperature is never an issue. As soon as you start moving, the temperature just drops. I've got the oil temperature sensor hooked up to the COSO digital speedometer gauge, and if you're sitting at idle in traffic, you'll see the temperature start to climb. As soon as you start moving, as soon as you start getting 50 kilometers an hour, the temperature just drops right away.
For the coil, I chose a 4-tower wasted spark logic coil. It's called a logic coil because the power to actually create the magnetic field is drawn separately from the trigger signal. So on a standard old style coil, the power wire and the signal wire are the same one. The Microsquirt can't handle that big voltage drop when typically the points would open and break that contact. So these coils have a built-in logic circuit where you're using a very a 5-volt very low amp signal to trigger the coil. So you either have to use a coil with a built-in logic board, or you can buy a separate logic board to handle regular coils. This seemed like a proven method, and I didn't want to try and do anything exotic that might cause me some headaches. So this coil was very popular in Europe, but not so much over here in North America. When I first bought one of these coils a few years ago, before the project was on the road, I had a hard time finding one for a reasonable price, and I ended up buying a cheaper Chinese one off of Amazon. Recently now you can buy a genuine Bosch one for, I can't remember, $75 or something like that. So it's pretty easy to find them now off of Amazon, and you can get a genuine Bosch one. Here's the gas tank. Down in this whole bottom area pretty much houses the standard Honda CBR600 fuel pump.
the nice thing about using this fuel pump was that it's a returnless design, so there's just one fuel hose coming out of it and one wire for the pump and the level sending unit. The downside is this thing just weighs a ton. It's heavy, so, but it is what it is, and it works, you know, and I knew it would work with the injectors and everything because it works in the standard Honda arrangement. So it pretty much takes up this, it's about this tall, just about touches the top of this lower section of the fuel tank.
For the wideband oxygen sensor, I went with a Spartan 2 from 14.7. This is really the probably the cheapest option you can find. It's like $125 US, and that comes with a Bosch LSU 4.9 that is like the latest oxygen sensor that wideband oxygen sensor that you can get. So that's pretty much it for the hardware part. You can leave now if you want, or if you want to stick around for another 15 minutes of long drawn out boredom, I'm going to talk about the software, the tuning software, and the Microsquirt controller and its software. To control the fuel injection and the ignition, I picked a Microsquirt version 3. That's based on a Megasquirt version 2, which is a older version of Megasquirt. A little simpler. It's a more of a lightweight version of Megasquirt. It doesn't have as many features as the Megasquirt, and what they did was they removed a lot of the built-in sensors, barometric sensors and relays and stuff from the board, so that they could get it down into a smaller form factor. So it comes completely built in a plastic case, and the case size, it's only about 3 inches by 2.5 or 2 3/4 or something, and about 1 inch deep. The bad thing was they put that big amp connector going into the case at 90 degrees. It would have been far better to go in one of the ends, which is more like every other OEM ECU that I've ever seen. So in theory, it's easy to package because it's small, but in reality on a motorcycle the wires come out of it in the wrong direction, and it's a real pain in the ass to find some place to put it. Stupid. You can tell it was done by car guys, even though it was supposedly for motorcycles and snowmobiles and stuff. It was done by car guys, and you can tell that. So the price on the Microsquirt is $360, and that comes complete with a 3-foot cable, or about $390 with an 8-foot cable. Why I picked it, some of the pros for it: it is relatively cheap, especially when you consider that it's also handling the ignition. So if you have to, otherwise you'd have to, you're not going to use points or something on an old bike and that's what you're working with. You'd have to go to a Dyna system or something like that, and you're going to spend another couple $100 and just on the ignition system. So when it's controlling ignition and the fuel injection, it's actually pretty cheap, and it will control the ignition up to, I don't know what the upper limit is, probably at least 14,000 RPM, maybe even more. There is a guy online I found who had one on a CBR250RR, and I think he was spinning that thing at 16,000 RPM, and that seemed to be about the upper limit of what it would handle as far as ignition. So the other thing, with the Microsquirt, there is decent support. There is vendor support from whoever you bought it from. There's a fairly active user forum if you've got questions. You can get a lot of help there. The software that you use along with it is called Tuner Studio, and that is free for the basic version. And then there is a modest fee of like $29 or something for the registered version that gets you the bulk of the features that you're ever going to need. And then there is a full version that if you're going to consider yourself an expert, or you're going to be helping other people or doing really weird stuff, then that's only like $50, and that opens up all of the features in the software. So with the Microsquirt and the Tuner Studio, it's pretty flexible. It'll get you running. I mean, and it will work with anything from a single cylinder lawnmower up to a V12 engine, and pretty much everything in between has been done. So no matter what you got, you can get it running with the Microsquirt. It handles the turbo information, using boost, and there's all kinds of, you can hook up boost controllers, and your ignition is tied into your manifold pressure, so you can control your ignition with it. It's actually it works quite well. Some of the cons with the Microsquirt, it only does batch fire or alternating batch fire, so you can fire all 4 fuel injectors at once, or you can set them up so you've got 1 and 4 firing together, and then 2 and 3 firing together, alternating. So it doesn't do sequential fuel injection. But from what I've read, it really, that's only a kind of a really only affecting it at idle, and helping with emissions. Other than that, it really doesn't seem to make much difference. And if you consider something turning 10,000 RPM, does it make a difference that it's firing them one at a time, or is it batch firing them? There's so little time between firing events, I don't think it really matters anyways. Getting into into doing your own fuel injection and stuff, with the Microsquirt, it is both simplistic and complicated at the same time. Compared to a Motec or something like that, a Microsquirt is like a stone compared to those things. But it is also very complicated for a beginner. It's probably the simplest system out there, and it's still very complicated for a beginner. The Megasquirt or Microsquirt started out as a very simple system, and it's been added to and added to and added to over the years as guys have requested more features and requested more flexibility in the type of engines that it will work on. So what you end up with now is a fairly mature product that has a lot of features that you don't need on a simple 4-cylinder motorcycle engine that isn't controlling air idle valves and isn't controlling a bunch of other features. So figuring out what you need to worry about and what you don't need to worry about is tough for a beginner. You don't know what you don't know if you don't know it, and so the manual is full of I found the manuals, they're comprehensive, but they're very difficult to read, because you get 3/4 of the way down a paragraph, and then there's it says, if you're going to do this, look here, and then that links you over into another section of the manual, and then you read 3/4 of that paragraph, and it says, if you're going to do this, read this, and you go off and you end up about 8 layers deep in this manual, and it gets pretty confusing. So another thing, even though there is support for it, it's not perfect support. The guys that are doing the hardware and the firmware, which is the basic software that the computer runs on, are one group of guys. The software for tuning it and for changing it and everything is a different set of guys from a different company. And sometimes those two things don't match perfectly, and then who do you go to? Is your problem a hardware firmware issue, or is it a tuning software issue? So when you read through the forums, you'll find all kinds of problems that where firmware updates didn't go properly and different versions didn't quite work with each other and stuff like that. So it's not a perfect system, but you can get, it's not perfect. Tuner Studio is the software that allows you to change the settings and control the Microsquirt. It's available from EFI Analytics, and it comes in 3 versions. I think there's a free version that is very light and doesn't allow you access to all of the parameters. It comes with a registered version that's about $30 or $50 or something like that, and that gives you access to pretty much everything you need as a beginner. If you're going to be trying to do some advanced tuning, then you need the full version that isn't much more. It's another $20 or something. But the basic version is going to give you pretty much all the control that you're going to need as a beginner to get running, and even a beginner with a turbo system. So when you first start into Tuner Studio, you create a new project, and in that project file it allows you to set all your initial parameters. That you don't have to set everything, but you describe the engine, what type of engine, what size of engine, how many cylinders, all the rest of it. You describe your injectors, how big your injectors are, so there's what type of ignition you have. That's probably one of the harder things as a newbie to get figured out. Once you get those settings entered, there are tools built into it that allow you to create your major tables that you need to run the engine. The 3 tables you need an air-fuel ratio table, you need a volumetric efficiency fuel table, and if you're going to use Microsquirt to control your ignition, then you need an ignition advance table. So there are tools available, and the primary one to get filled out is your air-fuel ratio table, and it does a pretty good job on its own, setting you up with a basic table that will get your vehicle running for absolutely it will. In fact, when I look at the table that I've ended up with my turbo bike, based on what I've read about fueling requirements for a turbo engine, the program, the table that was generated by the program is within within probably a half a point compared to my table. So it generated a perfectly usable table. The volumetric fuel table that it generated, on the other hand, was super rich. It'll get your vehicle running, but it's going to run rich. It ran so rich on that basic table that it was basically falling on its face. When I looked at the air-fuel ratio readings, they were 10.5, but I think that's as low. It took me a while to figure this out. That's about as low as the controller will read. So when I got the bike running, it would run up to 4,000 or 5,000 RPM or whatever, and then it would just die. And as I kept running it like that, it slowly got better and better to where it would rev to 6,000, and then 6,500, and then 7,000. But it was taking a lot of time to get there. And what I finally figured out by looking at the fuel charts was that as it was self-tuning, and it was pulling fuel out of those areas, it takes a while for it to do it. And right at that cutoff where it would fall flat in its face, the fuel was doubling. And I just kind of thought to myself, well, there's no reason for the fuel to double from, say, 6,500 to 7,000 RPM at full throttle. There's just no need for it. So I manually pulled fuel out of the top end, and then it would rev. And so that's a process of developing that fuel table. The ignition advance table was reasonably easy to build. I knew what a stock 400 Honda, I knew what the advance was when it was idling. I knew that it reached full advance by 3,000 RPM. And then I knew from reading my turbo books that I needed to pull timing out as the boost crept up, so there was a fairly standard amount to do that. So I was able to build that ignition table fairly quickly. So once you get the bike running, now what? It doesn't run well. And how do you get it to run well? So there are some built-in features, there are some built-in tuning features, as long as you have a wideband controller. There's a startup, warm-up tuning area that sort of handles, from as cold as you're going to use the vehicle. If you're planning on using it in freezing temperatures, you have to build that warm-up table when the engine is freezing. So that's a process. You can start it at any temperature and build your table, and then as you sort of move into the fall and the days are getting colder in the mornings, and you can go out and rerun that feature, and it will adjust that fueling to meet the target air fuel ratio. And that's how the tuning feature works. Whatever air fuel ratio you've put into your air fuel table, the system is going to adjust the volumetric chart to try and achieve those air fuel ratios. When you look at the VE chart, it's just a bunch of numbers, ranging from 0 to whatever, and it's based on your fuel pressure and the size of your injectors. So I guess in theory, probably 100 is probably, well, I don't know. I honestly don't. I can't even say how it works. They're just numbers, and so you just increase those numbers to get more fuel. You decrease those numbers to get less fuel. If you were to put in bigger injectors, you would have to redo that chart. If you were to change your fuel pressure, you would have to change that chart. Otherwise, if you increase your fuel pressure, it's just going to increase the amount of fuel being squirted in on every time the injector opens. So once it was basically running a little bit, but it certainly wasn't running good in my case, I was able to find a remote tuner off of the Microsquirt forums. The guy I found was in Minnesota, and he was a nice guy. He was very helpful. I think his base rate was about $150 US to help you right from scratch. That's someone that doesn't know anything, to get your system set up and running, and then to continue to tune it until it's running properly. I already had mine running, so I think he charged me $75. It was like half price because I already had everything running. But you're able to data log with the Microsquirt. So basically, if you can get it to reproduce whatever problem you're having, and you can data log that problem, send those files via email to him. The 2 files, one is all your settings is saved in a file, and then the data log is saved in a second file. You email that to the guy. He's able to look at, he's probably got more sophisticated analysis software, and he's able to change your tune for you and just email that file back to you. You can just reinstall it into the Microsquirt and then test it. And really, with him, it only took about 3 sessions, really. I probably only sent him about 3 data logs, and he was able to get my system running. But there was features in there that he knew exactly what to disable or what to fine tune to get the bike running. And who knows how long it would have taken me to find that stuff on my own. It was the best $75 that I ever spent. Along with Tuner Studio, also available from EFI Analytics is another program called Megalog Viewer. And again, I believe it's free for the absolutely base version. and then there's a registered version that's like $30 US, and then there's sort of a developer version that's $40 US. So when you want to data log something in Microsquirt, you create the data log, and then you can use Megalog Viewer to open up that data log and view the log files, and you can control what Microsquirt is going to log, and then you can control with Megalog Viewer what you are seeing and how you see it. So, you know, unless you're going to make yourself an expert, there's really no sense in having the full versions of Tuner Studio and Megalog Viewer, because there's just so much information there that if you don't know what to do with it, you're not helping yourself by being able to see it. The tuning guys that they're for hire, I'm sure they have the full versions of Tuner Studio and the full versions of Megalog Viewer, and they can see the intricacies of what's happening when you're transitioning on and off throttle, and your accelerator pump if you need it, and all the rest of that stuff. But if you're just trying to muck with that stuff on your own, you're going to be in for a long, frustrating time. I think it's better to just hire someone for what it was worth, wasn't expensive in the grand scheme of things, and got everything running really quickly. So congratulations if you stuck it out this long. I hope this gives you some sort of an idea of what's involved fuel injecting and turbocharging an old motorcycle. A lot of the principles would be the same, whether it was a motorcycle or a car or a different brand of motorcycle, whatever. It's been a fun project. The bike, as it sits now, I would say has been a complete success. The amount of torque available from this thing is astounding for if you've ever ridden a 404, they don't make enough torque to pull a skim off of a day-old pudding. This thing now starts building boost between 3,000 and 4,000 RPM on full throttle, and by 6,000 RPM it's building 8 pounds of boost easy. And I've been limiting it to about 10 pounds of boost. I don't have the upper end tuned completely yet, but between 6,000, 5,000, 6,500, 5,500 RPM and 8,500 RPM, it pulls really hard. I don't have any real numbers other than it'll stick with my buddy's RZ 350, which makes 55 horsepower and weighs probably 80 pounds less than my bike, and they'll stick side by side through the gears. So for me, that's a success.